Hey everybody, this is Derek Goodwin. Welcome to this week's Office Hours with eApprentice.net. Glad to have you all aboard. Today, Micah is going to do a presentation on creating tool libraries in Mastercam.
Today we'll be covering the basics of how to build a tool library in Mastercam. A tool library can be a real time saver both during program and out on the shop floor. In the past, when using manual mills, it was important for the machinist to develop an ear for the sound the tool made and adjust the feed rate or spindle speed accordingly. With the advent of CNC machines, it was possible to keep the exact same feed rate for a given tool, regardless of who was operating the machine. With the resurgence of manufacturing in America, maximum efficiency has become an important goal for each shop. It's not enough to have a general idea of how fast to run a machine tool. It's important to know right from the get-go. Tool manufacturers have caught on and now perform extensive testing prior to releasing tools to market, so shops don't have to. With new tool designs coming out constantly and being tailored to specific tasks and materials, it's important to be able to enter tool information into your tool library once, instead of relying on looking up information in notes or tool catalogs for each job and manually entering it. Today, we'll be setting up an aluminum library. Tools that will be permanently loaded into the machine, like shell mills, end mills, or center drills, will have a permanent tool number assigned, while other tools that may be used less frequently and swapped into the tool changer as needed will need a tool number assigned when programming. Building a tool library happens in the Tool Manager once a specific machine is defined. Since we're setting up a mill library, we'll select Machine Type Mill. In this case, the default machine type will work fine. Expand the machine properties and select Files. The Files tab allows us to modify or change a number of parameters. We can modify the machine definition or even change it to something else, like a Fadal or Haas machine. Edit the operations we're able to perform, and even edit the defaults within the operations. We can also edit or change our tool library. We can change our tool library to use, say, to a metric library or a large tool library by clicking the Open File button and selecting a different library to use. Or we can edit the current library by clicking on the exclamation point. We'll be creating a new tool library today, which involves quite a bit of work entering values, names, and definitions. To save some work, we can use the tools already defined in Mastercam as a good starting point. Click in the lower window to select a tool and use Ctrl-A to select all tools. Right-click and select Save Tools to Library. Since we're creating an aluminum library, let's call the library Aluminum Standard. Click the Open File button, select the library we just created, up the top here, and click Open. When we make changes to tools now, we'll be able to save it directly to the aluminum library. We'll start by editing our permanent tools. The first tool in our permanent tool library will be a 2-inch face mill. Click the Filter button, deselect all filters, then select the face mill button and click OK. Click the Filter Active box above the Filter button to display just the tools we set the filter up for. Select the 2-inch face mill, right-click, and select Edit Tool. The first tab allows us to define the overall shape of the tool. Our aluminum face mills come from Ingersoll's Illuminator line. Using the information from the catalog, we can set up some of the values. The tool will be tool number 1. Overall height, or how far the tool protrudes from the holder, will be 1.75 inches. Shoulder height, or how tall the tool itself is, will be 1.57 inches. The cutting edge of the inserts is 0.41 inches. The outside diameter of the tool is 2 inches, and the taper angle is 0 degrees. The Type tab allows us to define what type of tool this is, in this case, a face mill. The Parameters tab allows us to define the default parameters that will come up in the tool definition screen in the toolpath. We'll set the rough XY step-over percentage to 75% of tool diameter, finish XY step-over to 1.5 inches, rough Z-step to 150 thousandths, and finish Z-step to 10 thousandths. The inserts are made from carbide, and there's 5 of them in the tool. Go ahead and select carbide as our material and enter 5 as the number of flutes. The tool manufacturer hasn't supplied us with feeds and speeds, but we can come up with something pretty close and tune it as needed. Since we've entered the insert material as well as the number of inserts, we can click on the Calculate Speed Feed button to get a good starting point for the tool. Click on the Coolant button and turn Flood on. Let's rename the tool to reflect that it's in our aluminum library. Enter the manufacturer's tool code, which is Ingersoll 5H6G-20R01, followed by the inserts we're using, SHET 110516FR-P. If we click the Save to Library button, we can select which library to save this tool to, which is handy if you're setting up libraries for multiple machines. Since we're creating a generic aluminum library, we'll just save the tool when we save the library. And you do that by clicking OK. The next tool we'll program is the 3-inch face mill. Select the 3-inch face mill, right-click on it, and select Edit Tool. This tool will be tool number 2. The carbide inserts are the same as the other face mill, so we'll enter 410 thousandths for the flute length. The tool is 1 3/4 inches tall, and overall tool length out of the holder will be about 1.875. The outside diameter is 3 inches, and the taper angle will be 0 degrees. On the parameters page, we'll set up similar parameters with the 2-inch face mill. Rough XY step over at 75% of tool diameter, finish XY step of 2 1/4 inches, rough Z step of 150 thousandths, and a finish Z step of 10 thousandths. These values will automatically pop up when we generate toolpaths. The inserts are made from carbide, and there are 8 of them. Click the Calculate Speed Feed button to get a good starting point for feeds and speeds. Click the Coolant button and turn Flood on. Rename the tool to reflect that it's for aluminum, and enter the manufacturer's tool code. followed by the inserts we'll be using, the same as the 2-inch face mill. Click OK to exit. Let's see the changes we've made to these tools in action. Click OK to exit the Tool Manager and save the changes to the library. Open the Tool Settings page in the Machine Definition and select Use Tools, Step, Pec, and Coolant. Checking this option tells Mastercam to use the values we just entered into our tool library. Another good option to check is the warn of duplicate tool numbers. Since we'll be responsible to number any tools outside of our permanent tools, this option will ensure we don't assign two tools the same number. Just draw a rectangle on the screen to face. Select Toolpaths, Face. Click OK to accept the NC file name and chain the rectangle. Click on the Tool tab and select the library tool. The facing toolpath automatically filters to just end mills, and the two face mills are the first on the list since it's organized by tool number. Select the 2-inch face mill and enter an operation comment. You can see that the feed rate and the spindle speed are already set up for us based on what we entered on the Tool Parameters page. Click on Cut Parameters. The max step over of 75% is already set up for us. Click on Depth Cuts. Enable Depth Cuts. Notice that the max rough step and the max finish step sizes are already programmed in. We still need to enter the number of finished passes. Click on Linking Parameters. We'll go ahead and set up a clearance plane. Set retract and depth to absolute, and enter a depth of -150 thousandths. Click on the Coolant tab, and our flood coolant is automatically turned on based on what we entered in the tool setup. Click OK to exit and see the results. Now that we've begun programming tools into our tool library, we can program toolpaths with far less work than before. Let's add a few more common tools to our permanent machine library, starting with the 1/2-inch end mill. Select Toolpaths, Tool Manager. Click the Filter button. Click the None button to deselect all filters, and then pick the Flat End Mill filter. Select the 1/2-inch flat end mill, right-click, and select Edit Tool. Our end mills come to us from M.A. Ford, and they are Series 138. We have two 1/2-inch end mills with different flute lengths. The first has a 3/4-inch flute length, while the second has a 2-inch flute length. Consulting the catalog, we can see the end mill part number, shank diameter, overall length of 3 inches, and a flute length of 3/4 of an inch. The short end mill is assigned tool number 3 and has an overall length of about 2 1/4 inches protruding from the tool holder, a flute length of 0.75. Shoulder length may be different from flute length for certain tools, like our face mills, but since both shank and flutes are the same size here, it doesn't really come into play. When setting up tool lengths, Be sure that the shoulder length is shorter than the overall length and longer than the flute length to avoid any errors. We'll be roughing and finishing with this tool, so we'll leave the Both Radio button checked in the Capable Of field. To help set up parameters, we need to refer to the technical information available in the MA Ford catalog. The catalog gives values based on end mill size, which we apply in their formulas to come up with a feed rate and spindle RPM. Our rough XY percentage will be 30% of cutter diameter, finish XY step of 10 thousandths, rough Z step down of a half an inch, and a finish Z step down of 10 thousandths. The tool material is carbide. It has 3 flutes, and we'll be spinning it at 6,400 RPM. Since we have values that we got from the formulas in the catalog, we'll enter those instead of using Mastercam to calculate them. The tool feed rate is 105 inches a minute. Since the majority of our plunges are helical or ramped entries, or outside the material, we can up the plunge rate to about 75 inches per minute. And since there's no point waiting around while the tool cuts air on retracts, let's set retract speed to 200 inches a minute. Name the tool something distinctive like half-inch flat end mill, 0.75 flute, aluminum. Then enter the manufacturer's part number, MA Ford 138-50001. Lastly, click the coolant button and turn flood on. Click OK to exit. Now that we've defined our first half-inch end mill, we can define the second. Scrolling through the list, it appears we have only one half-inch end mill. While we can create a new tool from scratch, we can also create a new half-inch end mill based off the one we just modified. Select the half-inch end mill, right-click, and select Edit Tool. This will be our 2-inch flute length tool. It will be tool number 4, have an overall length of 3 1/4 inches, and a flute length of 2 inches. Notice that since the flute length is longer than the shoulder length, the preview window shows an X instead of the tool. Enter in a shoulder length of 2 inches. Click on the Parameters tab. These values are based off the short flute end mill and unlikely to produce a good cut with the extended flute length tool. We'll set rough XY step to 20% of tool diameter, finish XY step to 5 thousandths, and a finish Z step of 5 thousandths. We'll dial back on the feeds as well. We'll set 75 inches a minute for feed rate and 50 inches a minute for plunge rate. Since this tool is based off our other tool, the material and the coolant are already set up the way we'd like. Rename the tool to reflect the 2-inch flute length. And enter the correct tool code, 138500005. Instead of clicking OK, click the Save to the Library button. Select the aluminum library and click Save. Instead of clicking the green check mark to exit the tool definition page, click the red X to exit without saving any of the changes to the original tool. We now have 2 half-inch end mills, one with a 2-inch flute length and one with a 3/4 inch flute length. While it's easy enough to change existing tool geometry around to create new tools, how do you create tools that Mastercam doesn't have a standard definition for, such as the thread mill we created in the webinar before Christmas? One fairly easy way to do that is to import tool geometry, if your tool manufacturer can supply it. If not, it's possible to create your own tool geometry and use that to create the tool profile. To save you the tedium of watching me draw individual threads, I've created the thread mill geometry on a different level. There are a few rules to follow when creating tool profile geometry. The center of the tool tip should sit at the Mastercam world origin. Only half the tool needs to be drawn, and the two endpoints along the y-axis can't be connected to complete the shape. Reopen the Tool Manager, right-click in the lower field, and select Create New Tool. The first thing to do is select the tool type. Since Mastercam doesn't have a thread mill definition, this tool will fall into the undefined category. Next, we'll need to enter the tool parameters. Since this tool will not be part of the permanent tools, we'll make the tool number 0. This will serve as a reminder to assign this tool a number above 20. Using the parameters on the manufacturer's web page, we can fill in the fields. Shank diameter is 1/4 inch. Flute and shoulder length is 660 thousandths. Flute diameter is 235 thousandths. Tip angle is 180 degrees. And roughly 1.75 inches of the tool will stick out of the tool holder. To use the geometry we created to define the tool shape, click the Custom Level Radio button, enter Level 2, and press Enter to see a preview in the preview window. Click the Zoom button to see a close-up of the tool tip. Click on the Parameters tab. Since we weren't supplied any feeds and speeds, we'll have to use our best judgment. Let's set a feed rate of 50 inches a minute, a plunge rate of 25 inches a minute, retract rate of 25 inches a minute, and spindle speed of 5,000 RPM. The tool has 3 flutes, and it's made from tie-coated carbide, and it uses coolant. Name the tool something distinct, like 40 TPI thread mill, and enter the manufacturer's tool code. This case comes from Grainger, Since this is a tapping tool, we should save it in the tapping file. Click the Select button next to the tool file name. Select the Tap RH file and click Open. Click the green check mark to exit and save the tool. Then since our filter is active, we can't see it right now, but if we deactivate it, there's our 40 thread per inch thread mill. Since this tool is capable of cutting most any material, what if we need this tool for our steel or plastics library, but don't want to go through the hassle of entering all the parameters all over again? Select the 40 thread per inch thread mill right-click, and select Edit Tool. Click the Save to Library button. Select another library to save the tool in, and click OK. To see if the new tool is in the new library, exit the Tool Manager, click on the Files tab under Machine Setup. Change tool libraries using the Open File button. We drop that into our mill-inch library. Then click the exclamation point to open up the Tool Manager. Since the tool is tool number 0, it's the first tool in the list. When importing tools from other libraries, remember to change any necessary parameters, such as feeds, speeds, or coolant settings. While it may seem like a lot of work to set up a tool library, especially if your shop has hundreds of tools you use regularly, it will pay dividends down the line with decreased programming time and increased consistency of products and finishes on the shop floor. Are there any questions?
Hey, Micah, it's Derek.
Hey, Derek.
Hey there. Hey, fantastic presentation, Micah. Really well done. So we appreciate that. Okay, guys, we've got quite a few people out there today. So if you have questions, now's the time. If you would like to come on mic, use the raise your hand feature. Or if you would like to type in your questions, just type them in and we'll get to them as we can. So go ahead, folks. Time for you to join in and come on board with your questions. So let's see. I have a question that had come in from William a few minutes ago. Will this be available on video? And yes, we will make this available. As we go into the new year, as I mentioned earlier, all of us are kind of holding down full-time jobs while we do this, try and build this business on the side. So sometimes it takes us a while to get these videos processed and up online, but I will definitely do that, and everybody who's registered for this email will receive a link to it'll just be the YouTube version, but all the information will be there. So yes, so moving on to the next question. I've got a question coming in from Troy. Did you draw the end mill to scale? So you want to run with that one, Micah?
Sure. Yes, I did actually. So if we exit out of this, we can use the analyze function, and this line here, which represents half the shank diameter, is 1/8 of an inch long. And if we go in here and we do an analyze distance, these threads, 40 threads per inch is 25 thousandths per thread. So from the end of one thread to the end of next is 25 thousandths there. I don't know if that actually, well, I know it affects the threads to have the threads the right distance apart. I don't know if it affects the tool diameter at all, if this is drawn differently though.
Well, I would think it does actually definitely affect, although you do actually give a tool diameter in the tool parameter itself. So if you click into your tool parameters, and so see, you have actually given it a tool diameter there. So yes, that absolutely has to be the correct value, and yes, the threads per inch are important as well, really for verification purposes at this point. So the tool diameter is going to be very critical to your G-code output, because obviously you need the right diameter end mill, for the radius offset calculations that go out to the machine. Drawing the pitch on the screen, the pitch has to be correct as the feed rate. So as the XYZ feed rates are active, we need that Z retraction to raise, assuming we're thread milling from bottom to top. So at one full revolution of that thread diameter, the tool needs to raise in the Z direction by exactly the pitch. But drawing those teeth on the screen actually would not affect your G-code output, but it absolutely would affect your verification so that you can see this hole actually being milled on the screen while you're verifying. So hopefully we've answered that. Let's move on. Troy, if you have a follow-up there, just follow up and we'll get back to that. I have a question. I need this too from Thomas, but Thomas, I need a little bit more clarification on your question or your comment there, so if you can follow up on that. And perhaps it was just a comment saying, yeah, I need to build tool libraries. So give me a follow-up on that. Dale, let's see, I have a question. In Mastercam 5, use tool 5 versus .db with a question mark. I'm not sure what you're asking there. Let's see if any of the staff guys are available out there. Mike is online. Jay, I'm not sure if I'm catching you guys off guard as you work away in the background. Either of you guys out there, Mike or Jay, do you recognize the question there, use tool 5 versus .db?
Yes, I do.
Okay. Hey, Mike.
How you doing, everybody? Yeah, the tool DB is the new format for tool libraries, and I'd have to look up what that exactly entails, but it's basically going to be something that will come into play more in the next version, X6 and X7. So you're probably better off just using the standard Tools 5 library, but they both should work.
Okay.
Yeah.
Okay.
In other words, the Tool DB database is not fully supported in X5.
I see. Okay.
So
and when you
it will work for what you need it for in X5, but all the new things like tool holder assemblies and stuff like that it was really designed for aren't going to come into play until later on.
And when you say later on in the next version, are you thinking X7, or is this something that's still out there further?
X7. I think there's a couple things you can do with it in X6, but I can't be specific on that. I'm pretty sure. I think you can actually save some stuff to it. They say I've just never tried it.
I see.
It's not fully supported, you know.
Okay, well, fair enough. We had at least one CNC software employee online a little bit earlier. Looks like he's not online right now. So Dale, I will do a follow-up to that question, and we will actually we'll see if we can just add it to the end of the video when I process the video on YouTube. So that I think Mike has answered the question correctly, that there are enhancements coming, but what we'll do is we'll follow up with CNC software and see if we can just clarify that a little bit more. So thank you for that question, and thanks for jumping in there, Mike. That was something I was not sure about at all. So let's keep moving on. Frank has a question. How about saving the thread mill geometry to its own Mastercam file and using that file instead of a level in a part file to create the tool? And I'm thinking that that's completely doable.
There it is.
Oh, and I hear Jay just jumping online there.
Been trying to talk for a moment. Every time I said something, nothing happened. It took me a second to remember what Mike was talking about with the DB. Yeah, some of the newer stuff when it comes to the X7. If you put some of your tool data into DB format in X6 now, you'll be able to move some of that data into the newer tool manager, where in the older it's going to be harder to get some of your existing tools and data in if you're using the older format, for example, the 5 and earlier.
Right.
Okay, and do you expect in X7 that there would be some sort of an automated conversion process then, if you already have existing tool libraries, to convert to the new system?
I know there's supposed to be a little. I have to go back and look at it myself. I know I've seen a little bit of it, but it's not going to take care of everything because there's so much more offered that basically the idea will be that your tools definition, your basic tool definition will come in, but then you're still going to need to go into with the tool manager, the new tool manager system, and actually add your holders, add a lot more data about the actual material you're cutting, tensile strength, all that kind of stuff all will be added. So there's going to be the options are going to be so much larger that it's not going to bring everything because you don't really have everything there. The new system is going to offer so much more that it will make a huge difference for you. It's going to get more into the detail. This is what Micah did today was fantastic, but it's such a small sliver compared to what's coming.
Okay, excellent. So I think what we'll do is, this is a good subject. Let's not speculate anymore. I'm going to contact CNC, and if we're close enough in X7, then I'm going to go ahead and invite somebody from CNC Software with the inside information to actually come on board and do a webinar with us and show us what's new. If you're adding tool holders alone with real functionality to Mastercam, to the tool library, I would say that is a big deal. Being able to verify and machine simulation with tool holders would be fantastic, but let's not speculate on it anymore. We'll wait for CNC to come in and tell us what's coming. So appreciate that, guys. Stay online with me because I'm going to, let's see if you want to handle the question here. And I wonder, Micah, if you could bring that tool definition back up, and let's just jump back to Frank's question. Bringing in typically I do it on a custom level, but if you see the button down there at the bottom in the middle, custom file, and if you check that button, it's not typically the way I do it. So Jay or Mike, either one of you guys want to step in? How do you navigate to the file that you want to use if you use separate files for your custom tools?
You want to handle that, Jay?
Well, I guess it matters who. Sure. Either way, I didn't know because we both sit here and quiet going, okay, who's going to jump in first?
Yeah.
Actually, right now that he's picked that, if he says okay, a lot of cases what happens is when you pick that, say okay. In this case, nothing happens, but when you actually start to set up, and it's usually, go back into that file for me. On that, when you start to build it, it's going to be a custom tool, right, an item 5 tool. When you select that, when you're creating a new tool, it automatically asks you for the file. In this case, compared to a level where a level, of course, you just set it, or auto is going to be by tool definition using the existing. If you have not, when you're creating a new one, you want to draw your tool first, then you go in there and start to set up your undefined tool like you see here. And as soon as you hit custom file, it's going to prompt you, where is this file? And that's where you want to go and look for your geometry file. A lot of time I make them sometimes, and I keep them exactly with my customer folder. So I'll have I have my customers directory, and located in there is their under the customers, the projects, and under the projects I'll have tools. And if I have custom tools that I'm using like this, where I've drawn my own tool, could be a porting tool or something like that, that's usually what happens is I'll go there and they'll say, all right, and I go look in that particular folder, tell it it's that profile, and it should show you on there in that area to the right there your picture. But if it doesn't show you the profile, always remember there's a prompt that comes up whenever you make a mistake or it doesn't like the geometry. It tries to give you some type of information located just underneath where it says custom file, to just to the left of the green check.
Okay, so if I understood that correctly, then you would make one specific file for each custom tool. Is that correct, Jay?
Yes, this is, like I said, this is custom to where, like I said, sometimes I'm sure Michael's do the same thing, is that sometimes we'll draw them as a custom tool on another level, and then it's associated with that file. Or sometimes, for example, I have a whole library full of thread hops. Mm-hmm. So I've actually drawn a bunch of the tools and created those actual geometry files and then added them to the library, because each one's an individually different that I can use for different customers compared to using level, because I'm only using it for this one job, this one customer.
Okay. And I have a comment coming in from Mark saying, why don't you do a file save and show it? So should we try it? You want to prove it?
We can prove it.
Let's try it. So you want to save that out. So Micah, let's save that. Save that Mastercam file. You've probably already got it saved, and then let's try and just apply a thread mill to a circle and see what happens. And,
well, did he pick a file and define that file? Because let's go back. Let's real quickly. Go back to the picture. Sorry. Let's do one thing. Go to the last page. Down there where it says select, up, right there, select, and make sure you selected that profile. See, in this case, you got a tap right hand. This is where, I'm sorry, I should have also pointed out, when you first set it up, it's gonna ask you, prompt you. Now that you went back in, you needed to go back in here and define that tool. And also, by the way, where it says file name, when it's highlighted, if you know the beginning of the tool, say it's a spot deal, if you put S, it'll actually show you a list like that. See how it does at the bottom. So if you actually know the beginning of that name of that tool defined, that the geometry, you'll see it. It'll come up real quickly. Is it down the list like below? But do you know? Did you create this file as a separate file?
Yeah, I could probably.
You put it somewhere else. That's fine. It still works.
So now, if we
let's go to the undefined. Now you see there's your profile.
It is. Cool, and I picked that out based on just whatever geometry was in the file then.
Correct.
Okay.
So now when you say OK and you can save that, now it'll be associated to that particular, like I said, it'll be in your library. When you save it to your library, this geometry is associated to it. So of course you want to put the copy of this into your tool list, your custom tool list or whatever, I'm sorry, your standard tools where all the Mastercam tools are for mill. Because otherwise, if you go to another computer and you didn't copy your library and that other folder, you know what I'm saying, is it's a standard Windows slot. It's looking over where you just pulled it from.
Yeah.
And it's not going to look in the tool library for that particular one.
Right, fantastic. So we didn't need to actually go open a new file, because even though we are still in the existing file, you could still access that file to get the tool geometry.
Correct. Do you agree with me, Mike, on using when to use a save file compared to when to use as a level?
Oh yeah, I do. Only thing is, I just haven't used a file for probably like 5 years. So, and I'm testing it over here, and it's not working for me for some reason. I just haven't done it in so long.
All right.
Yeah, I just have a list. I have. Like yourself, you should, I most likely, because you have a library of port tools. So that geometry is, that I use for different projects compared to if used as a level, it's always saved with that project, and then I have to redraw it every time. This way I don't have to redraw it every time.
Right.
That I just go ahead and use. I have that as a library of porting tools, and I have a library of thread hops, different, standard, metric, things like that, single flute, multi-flute, that kind of stuff.
Oh, it's definitely the way to go. Yeah, it works fine for me now.
Good.
It looks like the trick is you can't, if you just open a tool and switch it from auto to custom, it won't prompt you. You actually have to go create new tool, and then you have to select the custom right away, so it will prompt you.
No, if you actually look at what Micah just did, like we just did, you actually, if you open up an existing tool and you were going to use that profile tool, all you have to do is go to the last parameter page and go to select for the tool the tool geometry file wherever you're keeping that. So if you can see the screen right now, you'll see that Micah's actually he went into that tool that we just were playing with. He went in, set for select where he had it. So that way he could go find the geometry, and it's somewhere else on his network. So you can take an existing, or for you, because you probably have, if you went into some of your files and you said, okay, this is a porting tool I've used many a times, and it's on a level, you would copy that. You would say save some, copy that tool out to its own geometry, put it in your tool library, go back in and pull that tool up in that particular project, and now put it to custom file, and now you could say save to library.
Yeah. So basically, you're just hitting select right there under tool file name. That way, you don't have to be prompted for it. Same thing.
Correct.
Right?
Correct.
Yeah, you got me on that one. Actually, thank you very much.
Hey, that's okay. I'll look for the. How this works, so you remember, Mike, is you have to scan in a dollar bill and email it to me.
Right, right.
You owe me $1.
Exactly.
So I used to use the files. Oh, excuse me. I used to use the file. That's all I used in the beginning forever, and then I switched over to using it by level right when they introduced that, whenever that was. So.
Yeah, it's a long time ago. I don't remember when it was, but yeah, on that, I use both. Like I said, it makes a difference on tools that I will use in different projects down the road compared to that's when I save and create it as a file compared to when I use a level. Is it, like I said, this is a custom tool, custom form tool just for this project only, and there's no reason to keep it in my library or anything. It's only used because if you create a custom tool, folks, and you don't save it to your library, it saves it with that particular project. It won't save it to your library, but it'll keep that file. So next time you go to pull it up, that file is that tool shape is associated with this particular file only. It won't be found in your library.
Right. So excellent, guys. I mean, that's always why I like to have both of you guys here, because usually between the four of us, we can figure out the answer. I mean, and obviously one other option is you could just create a Mastercam file. You could create as many tools as you wanted on different levels, and you could just do a file merge at any point in time. And
yeah, that's what I end up doing.
Yeah.
There's always, there's a lot of different ways to skin a cat. So let's move on.
Hey, I'm a cat lover. Be careful, please.
There you go. Well, I always say that there's a lot of ways to skin a cat, but in my kitchen, we skin it my way. So,
all right, Ben.
Here you go. Follow up to that, Dale. Can you set up tool libraries in a network? Let's do it real quick. If you guys want to say, I'm usually not using Mastercam on a network. Any network experts on staff today? I think the answer is that your tool library is in your shared Mastercam folder. Would that be the correct answer to that?
Well, it's in your shared directory, but you can copy that library to a network location, and then you're going to use under your system config where it talks about libraries, or you can do two different ways. Of course, you can say, hey, if there's a default library that we're all using, and that's just the one library, you can, like I said, just put it on the network somewhere. And if you wanted to default to that library, then you would go into your settings config and file configuration. You'll see one that'll say tool data. Go into files and get my glasses on here. The screen gets smaller. See, like it says, default library. And step to the right, post libraries, tool libraries. You'll see, for default. Hold on. Yeah, so it's right there. So you would actually, in that case, if you look, there's different options. So now you could go and say, hey, okay, here's my tool library. These are ops, actually, by the way. These are the default ops. So say cancel. And scroll it down a little bit under that, and see mill tool library. So in this case, it's looking for those tools. So now you would actually set that tool library on the network, on the server that everybody can share. So when they go automatically would default to that. You can also do the same thing as what's, for machine configure under your, Mike, do you remember if it's under the control or under the machine def that you can set what tool library?
It's in the machine definition under the general machine parameters. You can select your specific tool library and or material library there, and it will only be loaded when you load your machine definition.
Right, that particular machine definition. And then all you're doing is the same thing, is you're routing it from your local drive to the network drive, just so that it goes to look there by default instead of you having, where of course the other option is if don't do any of the things we just talked about, and when you say what tool when you go to get your tool and it says what tool library, you click and you can move your way to the server. But if you're going to go ahead and use a tool library that you're using specifically for different control definitions or ones that everybody's going to use, it's great to set it up as a default.
Right, perfect. I agree.
Fantastic. Thanks, guys. Okay, we're running short on time, so let's keep this going. This is excellent stuff. And I just sent Mike an email a few minutes ago. You guys might agree that I think the next topic we want to cover in this series is probably operation defaults. So now that we've showing everybody how to set up your tools so that they always work the way you want them to. Maybe next time we do a webinar, we'll show you how to set up your operations like Pocket and Contour and Drill and Tap so that they always work the way you want them to work. So if you guys agree with me, just say yes. If you don't, say no.
Yeah, I agree. That's a good one.
Okay.
Oh, can I just say no?
Just to create trouble, huh? Okay.
Just to beg the degree.
Right.
Just to degree,
So let's
exactly.
Yeah, we'll do that. So let's keep it going. Rick has a question. Can you do the same with single insert thread mills? Yes, absolutely, Rick. You just would draw it as a single insert thread mill, and it would just basically Mastercam would automatically output more XYZ circular interpolations so that end mill went all the way around, from the bottom all the way to the top. I mean, if you're just doing one part and you don't want to invest in specific thread mills for each different pitch, you can just have a single tooth thread mill, and then it can do any pitch you like. So absolutely yes. Let's keep going on here. I have a question from Gansham. In an industrial environment, should one go to the plant tool library or to a personal tool, or a personal tool library is necessary to be created? I would say that that's going to be under the category, Gansham, of either personal preference or if you are in a company environment, I would certainly say it should be set up as a company tool library. So if you're working in a flexible manufacturing cell and you're responsible for maintaining tool libraries that different programmers need to be able to access, absolutely you would want that to be public. We do not want different people creating different tools. This is something that needs to be managed very carefully. Now, if you're just a hobby guy in your garage and you've got a little, a Haas mini mill in your garage, well, you can just put it in your own personal folder. So it just depends what your situation is.
Yeah, because there's going to be multiple tool libraries in some cases, like larger companies that have horizontals, and they dedicate certain tools to certain locations in the machine. So in that case, for my Toyota with multi-spindle, it has two configurations, multi-spindle. I have a tool library for one spindle and tool library for the other, and if you're one of, say, 5 to 10 programmers, you don't want everybody, like you said, not everybody creating their own library. This library's already been set up because tool 1 is always going to be a 3-inch shell mill on that, and that's what you want to be able to pull from the library instead of you generating or recreating something new or moving the tools around that have already been existing. Right,
exactly. Okay, let's keep it going. I have a question from Jaime. Could you show how to add a 90-degree angle tool? So 90-degree angle, I'm not sure if you're talking about a 90-degree included angle tool, which would really exist as a chamfering tool in the library, or you could specifically draw the geometry, just exactly the way Micah drew the geometry for the thread mill. You can draw any form tool, any geometry you want on a level as Micah did, or in its own file if you're going to use the from
Micah,
file.
stay there.
And it sounds like Jay's got something he wants to add to that.
That's why I say, Micah, don't move, because this might be this question is that, for example, pick on the 2-inch face mill. All right, so that profile shows a 45-degree angle. This question gets asked to me a lot because people go in there, put 90 degrees in the taper angle trying to get a 90 degree because they have a straight insert. See what happens? Put it for 89 degrees. That's the closest you're going to get, for example.
Okay.
It's actually confusing because a 0-degree taper is a square taper.
Right.
So when I set up the shell mills in the presentation, once you set the outside diameter all set at 2 inches, these are 0-degree inserts in the shell mill. as
Right.
opposed to 45 would be different.
Or how we're looking at your second insert there would be set at a 45 degrees. Sometimes they're set at a different rake by whoever the manufacturer is. But yeah, the definite. That's what I was saying is I didn't know if he was saying about a 90 degree being a, like you said, a 90 degree chamfer tool or a 90 degree spot drill compared to a 90 degree on this, because this is where a lot of people go in there in that face mill configuration and they go in and they put 90 because they're thinking it should be at that direction. And it's not correct, and it gives you an error. So, like you said, is the zero actually is the correct answer?
Yeah, you know what that is, Jay, and I think years ago we used to be able to put 90 in there, and those of us who've been around for a while, but I think Micah has actually just identified either the workaround for that or the way it's actually supposed to be defined.
Right.
Yeah, so I think that's fantastic.
Except that, Micah, try to put the corner radius on the tool. That's the issue.
Yeah.
Yeah, that's why I didn't put a corner radius on it.
That's why a lot of people just use bull mill on it and just be done with it.
Okay, well let's back up a second then. Let's cover Mike's point real quick. So if we can go back into that shell mill.
It's right there at the top. Just go to use the one at the top.
Oh, all right, do that too.
Okay. So what Mike is saying, so go ahead, Micah, let's get that back to 0, 2 inch, 2 inch, so it's a square. And let's cover Mike's point. So go ahead, Mike. You wanted to have a corner radius on the insert?
Well, yeah,
Yep.
normally they're never going to be sharp.
Mm-hmm. Yeah.
And if you want to verify and everything, I mean, if you want it to work right, you have to have an insert. You have to have a radius.
Yeah. So what I think what Mike is saying, Mike Witten is saying here, is that you would just, in this case, with a 90-degree square corner face mill, you would not define it as a face mill. You would just define it as a bullnosed end mill and add the corner radius that you wanted.
Right. See at the bottom now. Now you get the error.
Yeah, unfortunately, that's what you have to do.
So let's go ahead and do that, Micah. So go to your second tab. Yep, define it as a bull, and then enter your values there. And
Yeah, and visually call it a. You
Right.
could visually call it a shell mill if you wanted, and it wouldn't make a difference.
Exactly.
Now go back to the shell mill thought and put in 89 and put a radius and see if it works.
Yeah, because it's nice to have it say shell mill.
Still getting the same error?
Yeah. Yeah, I even tried when I was going through this to rehearse the presentation, I even tried putting in a different outside diameter. So since it's got a corner radius and the sort of inside diameter here is 2 inches, if we make the outside diameter 2.124, oh, there it works. So it's that didn't work before, but I probably put the wrong outside diameter in.
So
So
you would
actually,
so you put the 2-inch outside diameter and you go to the inside diameter and you make that minus value for the inside. I wonder if that would work the opposite.
I tried
Yeah.
that.
So there, oh, but we have a 0-degree tool. So once you make it a 0-degree tool,
Right, but set it for 89.
What if you make
So
it 89.999?
Yeah, I was going to say make it 80 more in a half, for example.
Exactly. So you could do that. Let's move on. I think we got it covered. Troy made the same comment, 89.99. He's obviously come up against the same thing. Back in earlier versions of Mastercam, you could make that 90 degrees. So if anyone from CNC Software did happen to pop back on the webinar today, guys, we would love to be able to just call that a 90-degree insert.
Well, really, yeah. But if it's a 0-degree lead, it should be 0, shouldn't it?
Yeah, but is it not? It's which angle is it coming from?
It's I'm sorry, guys. I'm going to have to table the argument because we are 3 minutes past our time and we have a few more questions. So hang in there with me. Let's move fast, guys. I want to get us in the habit of finishing this on time. So
I got to get out of Dodge myself.
we all do. So okay. So Al, question was answered while we were rambling on there. Let's see. Another question from Al. If your shell has radii corners, does Mastercam account for this in the step overs? Well, the step over, jump in, guys, if I'm explaining this not correctly, but I think the step over is going to be set by the step over percentage that you set in your face mill operation. I don't know if anybody wants to counter me. If not, let's just move on.
You going to comment on that, Jay, or else I'll comment on that one?
Go. It's all yours.
Go ahead,
Okay.
Mike.
Well, what you got to really watch for, and this is how you can really make scrap fast, and using that shell mill definition, in my opinion, it can get real dangerous, because what it does is it's using the bottom diameter as the cut diameter. So it's going to set your step over to the bottom diameter. So if you had a 40, for example, if you had just a standard 45-degree lead shell mill, and it was, I don't know, let's say it was 2-inch diameter, let's say the bottom diameter was 1.6 and the outside was 2 or something like that, right? So it's calculating the step over to the bottom diameter. That's where it's figuring everything too.
Okay, I think you've answered that certainly better than I did there, Mike, although obviously what I said is true. You can set your step over in your facing parameters, but what you've identified is a potential for a serious crash.
Serious.
Yeah, so let's keep that in mind, guys. The bottom diameter there is what Mastercam will use, so if you're cutting up against a vertical wall, Mastercam thinks it's got a tool diameter of 1.6, but if you've got a taper angle in there, your actual diameter is going to be bigger than that, and you are going to get a gouge. Now, that would show up in Verify, I would think, based on the tool definition. Would you agree, guys?
Yeah, I believe you're right there, but you still got to be real cautious when using that.
You have to be careful. I agree. Okay, let's keep this going, guys. I think we answered Al's question there. And Al had also commented that, yes, an operations webinar would be great, so we will definitely put that on our list. Christian has a question for Jay. Are there any updates on putting together a class that you will personally instruct at College of the Canyons for Mastercam 5-axis? We're using the new 5-axis trunnion up there at the aerospace company where the off-campus classes are located. Jay.
Wow. He laid everything out there. No pressure. The pressure is not on me. I'm waiting for the school. The school is still closed until next week, and when it reopens, I plan on talking to them to see when I can get that going. As of right now, until the school opens back up, I was told to hold off until probably February. So I'm hoping as soon as I have something, of course, feel free to email me if anybody's got these questions too. Christian, feel free to email me at j@eapprentice.net, and as soon as I got that information, a date, I'll let you know.
Fair enough, and we'll make sure that we let you know that as soon as it happens, Christian. Thanks for checking in. Comment from Rick, I'm impressed. Multiple answers from highly skilled programmers. So Rick is obviously referring to Jay and Mike there, and Micah, and we appreciate it, Rick. Thanks for checking in. We do appreciate the comments. Let's see. Well, we're about 7 minutes over, guys. That's the end of the list of questions I have. If you have further questions, just send me an email, derek@eapprentice.net. That's DEREK @eapprentice.net. And while you're there, you could do the same thing, Michael@eapprentice.net, Micah@eapprentice.net, which is MICAH. And Micah is the one who built the presentation for us today and presented the tool libraries. And Jay@eapprentice.net. So thanks a lot, guys. Thanks to all of you. Appreciate the presentation, Micah, Jay, and Mike. I appreciate you guys coming in with color commentary and answering the questions that I can't handle. And hey, everybody, watch your email. I'll send you a link to this webinar, and you will certainly get an invite to the next one. So we'll say bye for now. Thanks, everybody. Really appreciate you spending time with the guys here at eApprentice.